Yes, in terms of introduction, I'm Adebisi. I live all my life in Ilorin, actually, growing up. Then I went to Bamidele University where I did electrical engineering. As you know, it happened in Nigeria sometimes. I happened to work in the bank rather than in an engineering firm uh, for 2 years. And after 3 years of frustration, I felt, look, this wasn't for me. So I came to the UK around 2002. I did my master's at Lancaster University. I did my master's in mobile communication engineering. During my master's, I kind of had the opportunity of working in a company owned by a professor. And while I was working in that company, I was offered opportunity to do my PhD. So I did PhD and then postdoc. So basically I was with the same professor, the same department for 8 years. And then I joined Manchester Met 2012 as a lecturer. I became professor 2018. It was about 2 years ago. So my broad area is connectivity. It's about connecting things to things. But over the years, I've done that in several applications, from transport to water, to electrical energy, to energy management systems, to smart buildings, smart cities, so on and so forth. And I currently lead a research group within the university. It's called Smart Infrastructure and Industry Research Group. Within the group, we have about 3 key components. One is smart energy systems. In smart energy system, we're looking at how you can use the whole concept of data analytics. You're using smart intelligence system, connectivity to make energy smart. So we have several projects in this area. We're currently working with different partners. We just finished one with South Korea and Oxford University Imperial College on what is known as peer-to-peer energy trading, how you can actually sell energy to your neighbor when you have excess of it from solar panel or you generate on site. Then the second group of people is, they're kind of, you can call them advanced signal processing or connectivity group. So these are guys working in IoT, which is Internet of Things, Internet of Industry of Things, and 5G, beyond 5G. There are other guys working in AI, artificial intelligence, data analytics, and with application in wider areas. Then we have the third group. These are guys working on modeling and digital twin for Industry 4.0. By that simply, you are creating a replica of a physical system. So if you want to create a digital twin of a building, you basically design that building in a software. So a model that is exactly what you have in the physical building, the rooms, where the chairs are, the number of people in the room, the quality of air that is coming in, the carbon monoxide, everything, you represent it in a software. And then you can then carry out research on the software, and you are getting real data from the physical system. You use that to optimize and validate your research in this software. And you might want to say, why would anybody want to do that? Actually, what is great about that is that you have a home, one house, you are using that for your research. What you can do is that, it's difficult for you to then create 20 homes because it's expensive. It's not easy. It's inconvenient to do that. All right. So what you can do is that when your software is behaving like one home, it is easy for you to replicate the software and say, well, I want to see what will happen in 20 homes, in 1,000 homes. In COVID-19, for example, you can do something like that. You create about 200 people in a community. Whatever is happening to them in terms of infection and how they are being treated and how they are recovering and so on, you get a software version of that. And then you can say, what if this is happening to these 1,000 people? What will happen to 10 million people, right? That's digital twin. So you have application of that in different aspects of life. So broad area is in application in smart cities, smart water management, intelligent transport, mobility, and so on and so forth. Like I said, we just actually completed a project called Triangulum. That project is a 30 million euros given to 6 partners across Europe to deploy smart city. And we use Oxford Road, which is in Manchester. It's called Oxford Corridor as a demonstrator for that smart city project. We had another one called CityValve. It's again 10 million pounds given by the UK government for Manchester City to demonstrate IoT in a smart city environment. and many other projects that we're working on using AI and so on. So this is part of what Industry 4.0 is all about. And actually this afternoon, I'm not going in detail into Industry 4.0. I'm actually kind of going to paint a picture of the skill gap that we have and how we are feeling it at Manchester Met University, and how, you know, participants here, we can have that debate later, how we can take that to maybe Nigeria and the rest of the world to see that this is something that is coming, this is something that is here, but obviously we need people to make it happen. And how are we actually upskilling these people? How are we preparing them for the future? Okay, so I believe for some of you, maybe not everyone, but you know, some of you, the question is, what is this Industry 4.0? Actually, Dr. Books might want to know this. Somebody sent me my picture, which I have never seen myself. Apparently, you've advertised this all around Nigeria and the rest. And somebody then sent it to me, and I said, oh, this is interesting. I didn't even know this was being advertised. And he said, well, by the way, what is this Industry 4.0? I said, oh, that's good. I need to then define it before I go into it. So what is Industry 4.0? You know, Industry 4.0 is just like talking about 5G, 3G mobile phone and the rest. You know, it's a generation of mobile phone technology. This is a generation of industrial revolution. So by Industry 4.0, we are looking at cyber physical system, a connection between cyber system and physical system. You have this fusion and they work seamlessly, all right? So intelligence system comes with assets and physical systems and critical infrastructure, and they all work together in industry to make things happen, sometimes without you. Okay, so that's what Industry 4.0 is all about. That is what we are going into. Actually, we've started a bit in silos, but that's what we are going into. So I'll just go into a bit of history of the previous one. So the first industrial revolution was actually, you could date that as far back as the end of 18th century. This was when, for example, you use water and steam to power mechanical manufacturing process. So in a factory, you kind of use steam, engine, you use water to drive a process. Things that are being done by human hands, you drive it using steam and water. And of course, that increased productivity. So a good example of this was actually the first mechanical loom, which was established in 1784. By the way, for some of us that are in Manchester, at least myself and Dr. Obooks are, Manchester was at the center of this revolution. If you go around Ancoats Road, you will still see the history of the use of this loom, the mechanical loom at the time. So instead of using hands to kind of weave cotton, you use loom, and it makes it faster, cleaner, and better. Then we move to the end, the start of 20th century. At this stage, it was just not mechanical, but you actually use electrical powered system to have a mass production using division of labor. Example of this is in slaughterhouse. So the first electrically powered slaughterhouse in a place called Cincinnati was actually formed around 1870. Okay, so that was the second industrial revolution. Then the third industrial revolution was very close to us. You know, maybe many of us here were actually born around that time. In this, you know, some or much before then, in the 70s. So we had the first programmable logic gate, PLC. So this is where you can combine electronics with IT, and then you make mass production line. You make that possible. That was the third industrial revolution. If you look at that industrial revolution, you will see that many of them are still here. When you go around with many of in the industry, what do we find with the PLCs and so on? So they are still there. But in the third industrial revolution, we are talking about cyber physical system coming together to make things happen. You could basically say in Internet of Things. You know, I'm sure many of us may be familiar with Internet of Things, but this is actually Internet of Things, where components, all the objects within the industry are all linked together and they work hand in hand to deliver high productivity. So when you look at all these 4 revolutions, industrial revolutions, really, all of them, there's nothing new. They're actually not addressing anything particularly new. All they want is better productivity. You want short time to market. You want increased flexibility. You want to boost efficiency. That's what all this is about, right? So it's actually the same thing. We've all wanted to weave cotton. So we used loom before, and then it was mechanical. We turned it to electrical, then we turned it to electronic, then we added IT to it. And the question is, can you then use robots to do the same thing? So that's what Industry 4.0 is all about. I hope I've been able to clear the air about what Industry 4.0 is for some of us. And in terms of, what is the core? What is at the core of Industry 4.0? So I would say communication, collaboration, effective decision-making, improved productivity, and people. So by communication, I mean, increase in communication has made it possible for us to be able to have software that can basically understand several languages. So that means I can be working with somebody in China and I don't need to learn Chinese, because there's a software that, can be translating things to me almost real time. And in the next few years, you will actually be able to have conversation with people seamlessly without having to learn a language. And many other things, including the use of mobile phone, which is really helping us now. Thanks to Zoom and other technology, even though we are kind of locked down in a way, we are still able to communicate, we are still able to have this seminar, right? So these are things that are driving the whole agenda of Industry 4.0. The other one is collaboration, of course. No one is an island. You can't do this, everything by yourself. So you need different people from different aspects of the society, different sectors, and you want to collaborate with them. We want to be able to make decisions quickly. We want to improve productivity. But the most important of this really are the people. Because in the end, yes, it is true, robots is going to be the one doing some of this job because they don't have emotion and they don't have to sleep, while we can go partying and go looking after our children and the rest. But actually somebody needs to program the robot. And when it gets damaged, someone needs to restore it, repair it, and so on and so forth. So that is why we need people. People is actually at the heart of everything that we're talking about. Okay, so stats, a bit of statistics here. So Industry 4.0, it says could add $14 trillion to global economy by 2030. 67% of UK manufacturers recognize Industry 4.0 as an opportunity. 28 billion is the amount expected cost reduction in the automotive sector alone between 2016 and 2020. That is if they go fully into Industry 4.0. Now we're doing a number of projects with them already. About 30% increase in productivity is expected when you have Internet of Things connected in your factory. Reduction in costs, about 3.8%, and so on and so forth. However, companies are still struggling. About 25% of the manufacturers feel that they have a sufficient understanding of Industry 4.0, only 25%. So there's still 75% that don't even know what it's about. And there are many of them that don't know what they can benefit from it. And even more importantly, they do not have the skills to make this happen. And this is where we come into all this. Engineers, academics, everyone working together. So really what I want to present to you in the next few minutes, and I'm aware of my time as well, is basically how we at Manchester Met, we are kind of doing this. And the picture I want to paint really is to let everyone see how they contribute to this. We are all stakeholders in this, the industry, academic, the government, everyone involved in it. And charitable organization like NSC as well. So these are, this is just statistic, a percentage of organizations that acknowledge that digital talent is widely, meaning that actually the gap is so wide now from those who know and those who do not. So there's that gap is really wide. So we need to fill the gap as soon as possible. So at MMU, what we did actually is we look at the 9 pillars of Industry 4.0. And the 9 pillars are what you have in front of you there: additive manufacturing, big data analytic, which, AI, machine learning, deep learning, also, and so on. Cybersecurity, autonomous robots, simulation, integration, Internet of Things, the cloud, augmented reality, and so on. And all these 9, we then started forming group of researchers, and then they started working with industrial partners so that we can cover as much as possible these 9 pillars. And those that we can't cover on our own, we work with partners in collaboration to make it happen so that we can close the loop. So a good example, we have a setup in a center called Prince City in the university. So please, I will encourage people, anyone, to just Google that and find out what Prince City does. It's amazing, actually. It started only about 3 or 4 years ago, not more than that. And it's a center, it's a 3D additive and digital manufacturing center based in Manchester. It has experts, which are designers, engineers, and we currently have a course, an MSc course in industrial digitization. It's amazing that actually it's a new course, but it's having more students than some of the old courses. We have people from diverse backgrounds. You don't have to be core engineer to actually do this, because remember, design and in industry is about creativity. It's not just core mechanical, electrical. It's actually people being flexible and being able to work in an interdisciplinary environment. Then this Prince City collaborates with large industries like Siemens. They also collaborate with small SMEs, small companies, and so on. So they have 32 powerful machinery that run Autodesk. They have large and varied type of 3D printers that can print plastic, they can print metals, print all sort of things. Like I said, please go on the website. They have video of some of these materials there. So then we have Cyber Foundry. Cyber Foundry is actually a group which is formed by 4 universities in the Northwest. University of Manchester, based led by Manchester Met. There's Lancaster University and Suffolk University. So these 4 groups, they got funding 6 million from EU funding to actually create this Cyber Foundry. Cyber Foundry is basically a center where people can go and be trained on cyber security, digital innovation, and so on and so forth. And the train, I think, is free of charge. If you are an SME, you can go there and be trained on how to secure your business. So we have our Fashion Institute, which is our design. So they bring design into engineering. So we have the Crime and Wellbeing Data Center. So this is how engineering is able to inform what is happening with people's well-being and crime, data analytics, and so on. Industry 4.0, as you can see, we are not addressing it just from engineering perspective. We're actually looking at it from it's actually housed by engineering, housed by the Faculty of Science and Engineering, but it's collaborating with many other institutes. So we have the Fuel Cell Innovation Center at Manchester Met, where we do innovation about using water, particularly hydrogen, in generating electricity. We have Institute of Coding, again, similar to Cyber Foundry. This is another institute we are working with University of Bath, and it's Coventry, and another university actually, in training people on how to code, how to write, anything around digitization. So this is what we are doing. But like I said, you do this collaboratively with other partners. So we have research centers like Advanced Material and Surface Engineering. We have my group, like I mentioned earlier on, Smart Infrastructure and all that. So these are the pillars. And these are some of the large companies that we are working with at the moment. UK agencies, Siemens, and so on. Actually, we have I don't know whether I've shown that, but okay, I'll show that later. So there's another thing that is important in Industry 4.0 that is really helping us. So at the moment, we are always between 1 and 6. At the time this slide was designed, maybe it was 4, between 1 and 6, the whole of the UK university when it comes to knowledge transfer partnership. For those of us in Nigeria, I'm sure Dr. Books and the rest in the UK, we know this. But for those of us in Nigeria, KTP, which is Knowledge Transfer Partnership, is actually funding that comes from government. It funds a project up to 67%. If you have an idea and you have a company that can work with you to deliver that project, they will pay for 67% if the company is prepared to drop 33% of their own side and so on. And I personally have been involved in 5 of them. I have 2 or so currently running. I've just completed about 2 in the past 1 or 2 years, and it's doing really well. We've made about 12.5 million since 2014 in just that project alone. The value of the project that we currently have is around 6 million. Like I said, we are like the top 4 in the whole of the UK in doing this. Now, the majority of this project are actually based in engineering or Faculty of Science and Engineering, and majority within that faculty is based within my department. And again, when you break them down, at the moment we have currently around 10 to 12 of 13. Industry 4.0 is 9 of them, where you are applying Internet of Things, cybersecurity, digital twin, connectivity, sensing, something that is making industry to be efficient is at the heart of this. So again, another thing that we do is we hold, there's this big industrial summit that is always organized across the world. So the last one was in Manchester here. So we are like the main partner there. As you can see, we had a good, space at the summit. And we also help students to, we asked them to do some innovation challenge where we gave the best person got £2,500 and all that. It was hosted at this. So maybe if you can, yes, let's just go through it a bit. Can we see that? Is it playing?
Yes, it's fine.
So these are some of the things printed, 3D printed. Okay. So,
Prof, can you take us through the video
again?
Yeah. So
all right. Well, basically, I think the video was just, we just took a snapshot of what happened at the Industry 4.0 Summit. It was a 4 days or 3 days summit with several thousand of people that attended the conference. So University of Manchester, different university, different companies were there. We took, this was just a snapshot of Manchester Met participation at the conference. So what you will see at the beginning will be the Vice Chancellor coming in, then the Dean for Research, and then there was a desk of our 3D printed example of things that we can now we can print using 3D printer. Some of them are just amazing. I mean, trainers that you wear, very fine grain materials that in the past you would have thought would be impossible to print. You can now design and print. And most of these are done by students. Okay, and they don't really need to be there forever. It's just MSc, because they are not going to lectures every day. There's a room. So for that lecture, there's a big yard. Everyone just sit there. You have your printer. Somebody comes with an idea, and you start doing projects. So that's how they learn. And by the time you finish, you are an expert, really. So okay, maybe I'll just play it again to give context. It's short anyway. So this is our section. The whole of this is our, okay, that's one of the printed design, a robot designed by a student. Yeah. That's the Vice Chancellor. Yeah, some of the printers. So that's the professor in charge of the print system. So innovation challenge by students, Cyber Foundry, some of the printers. This was printed, again, 3D printed. Okay, I think what is really maybe important in your video is basically to say that whatever we do, either as academic, it needs to be out there. So the summit was an opportunity to really take some of the things that we're doing within the faculty to take that to the rest of the world. Another thing is that you can't do it alone. So it's an opportunity to actually find other companies, businesses that are working in this domain that you can collaborate with. So I'm sorry, I'm getting to the end of the presentation now because of time. So I just want to present something that we just do. This is new. We just started this last year. And like I said, the first one we did was this MSc in Industrial Digitalisation. So with this, we are now thinking, you know, you can print even everything from cars to clothing to the entire house, you can print it. So for scientists actually exploring how you can print organs in the future. So the professor that was presenting earlier on, during this COVID-19, actually, one thing that he did, while within the first few, I would say the first week of us being locked down, one of the students and himself, they came up with an idea, very simple. They designed it, printed it, something that you can put on doors at the hospital so that people don't have to open the door. You don't have to use your arm like this to open it. You could just use this side of your arm. You open the door. In that way, you don't transmit. Very simple. But if you were to do that using the traditional way, you have to design, then you take it to the factory, and so it takes several weeks. This one, they just design on the computer, print it the way you print a paper. By the next day, maybe they have about 15. It went through the approval process, it got approved, and they printed more, and they started shipping. So that's the advantage. One of the projects I'm working on, which is about advanced metering for water management. So there was something we're trying to test. In the past, it would have taken several, months, because after designing that, they will send it to United Utilities, the water company, and they will have to check it and then see if it's okay. If it's not okay, they send it back. But with 3D printing, they design it right now. Somebody on the phone, they could just say, could you print it and test it for me, whether it's working? So you print it there, not here. You print it at the other end. And once it's printed, you check it, whether it's actually working. If it's not, you tell them, you give them feedback, and they can fine tune it. So you can do it in a day, maybe two, something that would have taken several months in the past. That's just a small pipe. So imagine being able to print spare parts for car, many things within our car that we wait to get from Germany and so on. If that can be printed in your office, that would be amazing. So we have an MSc course that's working on that. So we've had that now for a year, 2 years. But these are the new ones that we have now. MSc Mechanical Smart System Engineering. This is actually looking at Industry 4.0 concepts, such as predictive simulation, digital twin, like I said earlier on, and material science and so on. And then we have another one, which is MSc in Electronic Smart System Engineering. This will be looking at robotics, smart power grid. Some of my work will be going into this, autonomous vehicle. We're looking at electric vehicle, monitoring system, and so on. And don't forget that part of Industry 4.0 is that everything is joined together. So project management is also, at the heart of this. So we have MSc Engineering Project Management. And this course is actually, you can either do it in one year, 12 months, or 24 months with optional placement year available. And this is open to both graduates, UK residents and those that are coming from abroad. So we expect that this will be a very popular course. So this course also is actually, we are running it in collaboration with Siemens in what is known as connected curriculum, in collaboration with a company called Festo. It's a large company in Germany, and also with Prince 2, Profibus, Profinest, and so on. So these are some of our programs, some of the software company we are working with. Autodeck, for example, we have full license from them, very strong collaboration, which maybe only about 4 or so universities in the whole world have. And we have some of these software companies. So this is an example of what our MSc Industrial Digitalization student did last year, sportwear project. So they designed some intelligent sensors in footwear. They have generative design, footwear that can just almost fuse with your leg. It's as if you are not wearing anything. They're using 3D scanning, 3D printing, and so on and so forth. So that's, if you want more information, feel free to contact me. But actually, we have an academic lead for Industry 4.0 within my department, who is actually just leading the whole Industry 4.0 strategy. His name is Dr. Carl Diver. So thank you for listening. I hope I can take some questions.
Thank you so very much, Professor Adebisi, for that very insightful talk. I think we have questions already.
Okay. Are they typed out, or?
I will read out to you.
Okay. Good. All right.
Yeah. It is interesting to know that the names on your last 2 slides, you poached them from my university. So.
Yeah, absolutely. Even my dean came from your university.
So we are one and the same.
Yeah, it's the same. It's just one road in between us.
Yes. I think the first question here is coming from Abdul. He said, at the Print City, are there any opportunities for research? Do they have any studies on the make properties of 3D printed products?
Yes, that's what it was established for, actually. So, I mean, like I said, this 3D printing or Print City, is a whole concept that it can take us half a day or a day to do a workshop. Actually, normally I usually bring people, directors, people high up, my collaborators. When they come to visit me, I ask them to go spend at least 30 minutes there. It's really very difficult explaining, because I am there, but actually I realized until I actually went there myself, I couldn't believe some of the things that are happening there. Necklaces, chains that you wear, as tiny and fine-grained they are printing it now. They are using 3D printing to print them out. So it's amazing. So yes, it's actually about research, because what we do is, as you know, my university was a former polytechnic. It was established in 1824. Then went on and on from colleges and so on. It was fully fledged university from 1993. So it's hands-on. Things are actually hands-on. And what we pride ourselves of is we do research-informed teaching. So we want to get our teaching right. We want it to be super duper at the top level, but we apply research elements. So all the guys involved in the Print City, they are researchers, but we do that. Our impact to the society is through our teaching and the way we relate with the SMEs.
Thank you, Prof. This question is coming from Benjamin. Looking at augmented reality and virtual reality, how can it improve construction processes in the building services industry?
Okay, so again, I say this so when I'm teaching, I say to students, the best way to learn you get a lot. Sometimes you think you rely too much on your ears, but actually eyes get more information than the ears. So what augmented reality, digital twin, and these technologies, what they kind of help us to do is to use our senses better. So because you can visualize things, because you can feel, you can kind of have an idea of how things look like, your decision process is better, it's more efficient. So in construction, for example, instead of you can basically create new business model. You can make informed decision based on augmented reality because you have something that is cheaper in front of you. I mean, cheaper, it costs money, but in terms of scale up, it's easier to scale software up than to scale hardware. Because actually scaling hardware up or trying to test that hardware sometimes is not a function of cost, it's more of a function of even risk. You want to risk your life. So if you want to test that, if I touch electricity, will I die? For example, you don't want to do that in real life, but you can actually get a software to simulate it, and then you use human to test it, a human who is a software to check whether we work. Yes, I think it finds its application really well in any sector, particularly in the construction industry.
I think we have more questions. I hope Prof will not get too tired.
No, not at all. I'm just worried that you have your time, but if you don't mind, I don't mind.
Okay, thank you very much. I think this is coming from Dr. Omorege. How do you relate the application to the color limitations, especially vital of functional parts?
What? I don't understand that. Color limitation in what sense?
Perhaps maybe the question is looking at color. Are there certain colors that you will find difficult to print out?
All right. I thought he's talking about color of human being. Okay, so to be honest, when it comes to the specific of that, will be, I think guys who are into 3D printing is specific. We'll be able to answer that. But from some of the video that I played earlier, and actually picture, if you go to Print City, just Google it, MMU, Manchester Met University Print City. Click on it, you will see loads of things that they've printed already. And then you'll find that I don't think color is a limitation. But even if color were to be a limitation, that's why we are discussing what we are discussing now. Because the more students that we train, the more people that are actually getting their PhDs and doctorate in this area, the more that we'll be able to bridge this gap. If there's a problem in color, there's a challenge, a gap in this area, that is how to fill those gaps.
Thank you, Prof. I think I'll take just two more questions, okay? But I'll be selfish and ask mine before I take the last two, please. Prof, I wonder if you could comment, how will us as a country, in Nigeria, for example, or the likes of the developing world, how can we leapfrog the challenges of skills gap? Because if we are to go through the expected route, I don't think we will ever catch up. I wonder if you could comment on and address that, please.
Yeah, I've actually, I don't know if I wrote one article to Business Daily about 4 weeks ago, and I was asked questions similar to this in terms of our education. I mean, Business Day Nigeria, not the UK one. To be quite honest, my approach or mindset to this has not changed, even though I've left Nigeria for 18 years. And this is really to see this as opportunity. I think number one is for us to, as a country, to maybe just forsake this idea. We should leave this idea of we can't do it. And when we are asked why, we give so many reasons why we cannot. I don't particularly agree with that because I actually think we can. So that's number one. Number two is actually to say we can even more than many countries in the world. And I'll give you many examples, but there's no time to go through it. I can give you my personal example of how I came with my colleagues from Adebisi University. Two of us, came here to study. When we arrived, of course, we arrived thinking we didn't know anything because they did not teach us computer and so many. But actually, before you know it, by half mid to the course, actually, we're almost the top of the class. Why? because there were things that we actually have them really well from ABU. I mean, some of them you might think they are not good things, but by the time I got here, I realized they're actually good. You know, I was studying with lantern. I was waking up in the night when I'm going on through my lecture and there was power cut. We run to the room to go cook beans or do something. Resilience. So we had this go for it kind of attitude, okay? And by the time we added that go for it attitude, yes, the software we didn't know, which some people knew 4 years before us, we were able to study overnight. And tomorrow when we are discussing with them, they thought we've been using it for months, for years, okay? So how can Nigeria leapfrog? I think it's just that attitude of let's go for it, because I think we can do it. I mean, some universities are already doing what I was thinking about 4 or 5 or so years ago in terms of publication. So when you go to Nigeria university, we say, well, you know, it is because it's Nigeria, we cannot do work at high level. And I said, well, but I've met people from other countries, okay, Libya, I don't know, Iran, and so on, that are not necessarily the Western world. Go check their publication. They are not benchmarking their publication with Africa or their region. They benchmark it with the world. So I think we can definitely do it. Another thing that in the past few years I've also come to understand is that we rely too much on government in Nigeria. I agree that government should help, but actually I think sometimes we need to start doing something on our own, individually, collectively, as a university, as a group, NSC, you know, you start something, and it's easier to showcase what you are doing to somebody to then say, look, I have done it up to this level, support me to get it to the next level. So the answer is yes. And the answer is that we can actually do it faster. Why? Because we do not have the baggage, the legacy, which they have, which makes it difficult for them actually to stop some of the things they've been doing for many years. Because we haven't done so much, actually, it means we can just stop and start something fresh and then go quicker than them. So I'm actually very, very confident that we can.
Thank you so much, Prof. I think we have to leave it there, but I think if Prof gives me the permission, we can upload the slide on our Facebook page, so for members to download, particularly those who joined us late. And
so do you have the copy? Do you have the copy, or I will send you?
You will say